Alright, we're going to look at binomial theorem and how it's used for the expansion. So, first thing we need to start off with is knowing what factorials are. Factorials show how numbers are multiplied and it decreases by 1 each time. So, if you have a look here, 7 factorial for example, 7 times 6 times 5 times 4 times 3 times 2 times 1, you always stop at 1. And then you can write it with other factorials to simplify it down as well. Alright, evaluate 5 factorial minus 3 factorial plus 50 factorial over 49 factorial. So the first one, we have 5 factorial, which is then 5 times 4 times 3 times 2 times 1, which then gives us 12, 120. And then 3 factorial gives us a 6, because that's 3 times 3 times 1. Now 50 factorial over 49 factorial. If you want to go through and work it out, be my guest, but I'm not going to. You can convert 50 factorial to 50 times 49 factorial. The 49 factorials are the same, so that gives us a 50. So then we actually have 120 minus 6 plus 50, which then gives us 170 minus 6, which is 164. Combinations are normally used more for probability, except in this case. What we can do with combinations is we can quickly work out stuff. On your calculator, there is a function for it called NCR. I will show you that a little bit later on, but for now, to work it out, we need to write the factorial of the top one over the bottom one, and then subtract the 2. So then we get 8 factorial over 3 factorial times 5 factorial, which we then get 8 times 7 times 6 times 5 factorial. 5 factorials cancel, and then 3 factorials 3 times 2, which then gives us a 6. So we actually have 6 because the 5 factorials cancel. You have 3 times 2, which is 6. 6 and 6 cancel, so then we're left with 8 times 7, which is 56. Alright, now to quickly expand, we can actually use the factorial notation. So let's do the first one as an example. We want 3 to the power of x to the power of 4 plus 4, 1. Write up the first one, which is 3x, 4 minus 1 factor power times 2 plus 4, 2, 3x, 4 minus 2 factorial. Then we have 2 squared, 4, 3, 3x, 4 minus 3, 2 to the power 3 plus 4, 4. Alright, now 4, 4, 4C4 will always give you 1, and then this other one's a 1, so then we actually have 2 terms at the end where we have 3 to the power 3x all to the power 4, which then gives 81 to the power 4, and then the one at the end here is going to be 2 to the power 4, which is 16. Right, 4, 1, we then have 3 factorials, then that gives us a 4 times, we have 3 cubed, which is 27, x cubed times 2, 4, 2, I might move this back a bit more first, 4, 2, so we have 4 factorial, 2 factorial, which then gives us 6 times 9x squared is 4. Then 4, 3 is 4 factorial, 3 factorial, 1 factorial. So then we have a 4 again. 4 times 3x times 8. So then 81x to the power 4 plus, what's that? 8. 8 times 7, 56. 8 times 2, 16. So 16. Seems right. Sorry, I didn't bring a calculator. Yeah, it's 216. X cubed plus 36 times 6, 216 again. 12 times 8 is 96. And there you go. Alright, if we want specific terms, so find the fifth term in the exponent. Now, whenever you're trying to find the terms, we have n r, and we have x n minus r, then y r. Now, because of that, if we want the fifth term, we always need to do 9 minus 4, which then means our n is 9, because that's n, that one doesn't change. However, we need r of 4. So then what we're actually finding is 9, 4, x over 2, 9 minus 4, which then gives us our fifth expansion. Oh, actually, no, it starts off with 0. So then 0, 1, 2, 3. Yeah, that's right, yeah. And y over 3 is a negative, so don't forget the negative. So 9 factorial over 4 factorial, 5 factorial, 9 times 8, 7 times 6, over 4 times 3 times 2. Because the 5 factorials cancel. 14 times 9, 126, times x to the power 5 over 2 to the power 5, which is 32, times whatever 4, because with 2 to the power 4 the negative cancels, and 3 to the power 4 is 1. And simplifying that down, we would have that. Alright. Identify which term in the expansion wait, 9, 8, 7, 6, 5, 8. Identify which term in the expansion of that would contain x to the power of 8 and express the coefficient of x to the power of 8 as a product of its prime factors. So, because this time it's x squared, we need r to be equal to 4. Now n is equal to 12. So then we have 12, 4, 8 of 12 minus 4, and then negative 3x squared to the power of 4. Then simply expand that out. So then we have 12 for, like I said, use your CAS for this if you need it. 12, 11, 10, 9 over 4, 3, 2. Yep, and then 2, 5, 45, so that's, I'm just gonna leave them. Oh, it says coefficient as its prime factors. Never mind, don't need to do that. So 11 times 5 and 9, 8. 8 is to the power of 8, and then we have 3 to the power of 4 times x to the power of 8. So that's right. And then we have 9 is 3 squared. So then we have 3 to the power of 6. 8 is 2 to the power of 3. So then 3 times 8 is 24 times 5 times 11. So there's a coefficient of 8, x to the power of 8. All right. Oh, this won't disappear now. Oh, that's how you load it back up. Let's see. Okay. Now, what I want you guys to do, go on the main menu. When you're on the main menu, you may want to clear everything out. Whoops. You may want to clear everything out so that you don't have a giant screen. You don't have to. Now, before you do anything, I want you guys to make sure that this is in standard mode down here. Okay? If you don't have it on standard mode, and if it's in decimals, sometimes these fractions will not pop up for you, and you'll get decimal numbers which will not be acceptable for a lot of the solutions. So make sure it's in standard. If you do need to convert it to decimals, you can always just press the button on the top left anyway. Okay? Now, to find your commands, first thing you might want to do is to find a factorial command, which I cannot remember where it is. There we go. If you click the arrow down here, go to advanced, there it is, okay? It's a factorial. So if you wanted to do 5 factorial, there you go. Can I resize this and make it bigger? So it's not so. Is that bigger? I don't know. I'm just going to keep going. All right. If you want to find NCR, so if you want to do 5, 3, you have to actually click the NCR one first. And then you do N, then R. So 5, 3. Okay, there you go, 10. So I got that right. Cool. Now, if you want to find the bigger numbers, say that one, you want to do 9, 4. Let's see if I got that one right. Times, oh, actually, you guys are going to use the keyboard one. Where is it? Times. And what do we have? So if you want to make it look exactly like the screen, you might want to look for the math one. So then it pops up as a fraction like that. X over 2. Then power. Like that one. 9 minus 4. And then times. Open up another bracket. Y over 3. Oops, with the negative. Close the bracket. And then put a 4 in. Yes, I got it right.